In this video, we're going to talk about sequences. We're going to start with some definitions. A sub n is the symbol that we use for a sequence. N is the term number. So an important thing to remember with a sequence is that the subscript is the term number. A sub n is the term value. We'll see that a little more clearly in some examples. An explicit rule for a sequence does not depend on the previous term. The rule is written in terms of n, the term number. So for this sequence, I plug in the term number, multiply by 3, and add 5 to get the term. So for example, if I wanted to find the 10th term, I would plug in 10 for n. I would get 35. So the 10th term is 35. A recursive rule does depend on the previous term, and it always requires two parts. We need to identify the first term, in this case it's 5, and then we need to identify how we get the next term from the previous term. So that's what the second part is. This is saying to find the next term, take the previous term and add 3. So my second term would be 8, my third term would be 11, and I would add 3 to the previous term to get the next term. This is more similar to Anita's pattern, where we are basing our next term off of the previous term. So let's do some examples. We want to write the first 4 terms of the sequence. Our first sequence is a sub n equals 3n plus 4. So this is an explicit formula. I'm going to plug in the term numbers 1, 2, 3, and 4 into n to get the terms. So my first term is going to be 3 times 1 plus 4, which is 7. 3 plus 4. My second term is going to be 3 times 2 plus 4, which is 6 plus 4, which is 10. For my third term, it's going to be 3 times 3 plus 4, which is 9, plus 4, which is 13. And for my fourth term, it's going to be 3 times 4 plus 4, which is 12 plus 4, which is 16. So my first 4 terms are 7, 10, 13, and 16. Let's look at another example. In this example, we have n in 2 places in our formula. So I need to plug the term number into both ends. So let's start with a sub 1, the first term. It's going to be negative 1 to the first power over 3 to the first minus 1. Negative 1 to the first power is negative 1. 3 to the first power is 3, so this is going to be negative 1 over 2. For the second term, we have negative 1 squared over 3 squared minus 1. Negative 1 squared is positive 1. Negative times negative is positive. Check it on a calculator if you aren't sure. 3 squared is 9, and 9 minus 1 is 8, so that's 1 over 8. For the third term, we have negative 1 to the third over 3 to the third minus 1. So that's negative 1 over 27 minus 1, which is 26. So negative 1 over 26. And lastly, for my fourth term, I'm going to plug in 4. So I have negative 1 to the fourth over 3 to the fourth minus 1. Negative 1 to the fourth is again positive 1. And then this is 81 minus 1, which is 80. So positive 1 over 80. So what happens when I have this negative 1 to the n power is the effect that it has is that it flips the sign from positive to negative as I go through my sequence. So negative 1/2, positive 1/8, negative 1/26, and positive 1/80. So those are my first 4 terms. In number 8, we have a recursive sequence. So now I have my first term, and I'm given a formula to find the next term from the previous term. So when we have a recursive sequence, the first term is very easy. In this case, it's 5. So they're telling me exactly what it is. Now for my second term. What I'm going to do is take the previous term, multiply it by 3, and add 2 to get the next term. That's what this formula is telling me. The an minus 1 stands for the previous term. So this is going to be 3 times 5 plus 2. Which is 15 plus 2, which is 17. So now for my third term, I'm going to do 3 times my previous term, which is 17, plus 2. 3 times 17 is 51, plus 2 is 53. And then for my fourth term, 3 times 53 plus 2. So 3 times 53 is 159, plus 2 is going to be 161. So my first 4 terms are 5, 17, 53, 161. And finally, we have this notation called factorial notation. Factorial notation means that you multiply the number n, whatever is factorialized, by each number from n down through 1. So if it were 5, it would be 5 times 4 times 3 times 2 times 1. 0 factorial by definition is 1. So now we're going to write the first 4 terms of this sequence that uses factorial notation. I'll give myself more space. So let's start with a to the 1. So again, notice that we have multiple places where we're plugging in the term number. N is plugged in the power on 2, and it's also plugged in the denominator. So we have 1 minus 1 factorial. So 2 to the first is 2. 1 minus 1 is 0. And as we see up here, 0 factorial is 1. So this is going to be 2 over 1, which is 2. Second term, 2 to the second over 2 minus 1 factorial is going to be 4 over 1 factorial. So 1 factorial is just 1. There's nothing else to multiply by since we're already at 1. So the answer here is 4. A to the third is going to be 2 to the third over 3 minus 1 factorial. 2 to the third is 8. And this is 2 factorial, which is 2 times 1. 8 over 2 is also 4. And finally, for my fourth term, we have 2 to the fourth over 4 minus 1 factorial. 2 to the fourth is 16. 4 minus 1 is 3. So we have 16 over 3 times 2 times 1, which is 6. 16 over 6. If I simplify that, I get 8 over 3. So we have 2, 4, 4, and 8 thirds.